Hi everyone, welcome to the self-check section 3.1 video. So let's go ahead and check out question one. So question one says a fair six-sided die is rolled and we want to describe the sample space. So since the sample space is going to be just one, two, three, four, five, and six due to just being a six-sided die. Okay, so let's go ahead and look at the rest of these questions. So we want to identify each of the following events and compute their probability. Okay, so B is event T, and that's when you roll a 2. So we really only have one option for rolling a 2. So event T will be just 2. And to calculate the probability, it would be probability of T, so P of T, and there's only one chance out of six we're going to roll a 2. So the probability of this is going to be 1 out of 6. So 0.166716, or the decimal is okay. And remember, probability is 4 decimals. All right, let's go ahead and check out some other questions. So event A is roll an even number. So we only can roll an even number 1 through 6 with having 2, 4, and 6. So essentially, A is going to equal 2, 4, and 6. And the probability of rolling an even number, it's 3 out of 6. So we would have 3 over 6, which can just be the same thing as 1/2, which is the same thing as 0.5. And if you want to, you can say 50%. Okay, for question D is event B, roll a number that is less than 4. So that's not including 4. So I'll say not including 4. It's all the numbers are less than 4. So B will contain just 1, 2, and 3. Those are our only options. And then the probability of rolling a number less than 4, we have 3 options here. So that would once again be 3 out of 6, which is 1/2, which is 0.5, which is 50%. Okay, moving on to question E, the complement of A. So remember, the complement of an event is written sort of like a bar, like A bar, and it's the exact opposite of everything that's an A. So A was rolling an even number, so that means the opposite of rolling an even number is odd. So this means that it will be 1, 3, and 5. That's the complement of A. And so if we want to calculate this probability, we have 3 options again. So 3 out of 6, and that's just 1/2, and that's just 0.5, and that's just 50%. Okay, moving on to givens. So A given B. In givens, we go to the space that is given here. So we go to the B space. In the B space, we are at 1, 2, 3. And we want to have A given B. So here we are in the B space. The only number in the B space that also belongs to A is just 2. Let me circle that again. Here's the B space. I want to see the probability of A coming in the B space, and that's just 2. So here, A given B is just the number 2. And when we deal with givens, our space shrinks, so our denominator gets smaller. So the probability of A given B is going to be just 1 out of 3 because B only has 3 numbers, and the probability of 2 coming up in there is 1 out of 3. So that's just 0.3333. That's also just 33.33%. Now let's look at B given A. So B given A, we're doing the exact opposite now. We're going to A, and we want to see if anything in B is going to come about in A. So here I only see 2 for B that comes in A. So once again, we're going to have the same answer, just 2. And we will have the same exact probability of 1 out of 3, 0.3333, which is the same thing as 33.33%. Okay, let's move on to H, A, and B. So A and B is the intersection of A and B, the overlap. And really the only overlap of A and B looks like it's 2. That's the only number they have in common. So once again, we just have a set 2. And now the probability of A and B, we're going back to out of 6 because we're looking at the whole dice here now. The probability of rolling A and B is just one option 2. So it would also just be 1 out of 6 chance, which is just 0.1667. So A or B now. A or B is everything in A and everything in B. So we're going to combine 2, 4, 6 with 1, 2, 3. You don't have to double count the 2. So A or B is going to be 1, 2, 3, 4, 6. We are missing number 5 here, but that's because it was in neither A or B. Okay, so now the probability of A or B, we have 5 options here. So it'll be 5 out of 6, which is 0.8333. So now for part J, we have A or B complement. Let's go ahead and fix this. Let's put a bar. So let's go ahead and say what B bar is anyway. So B is number less than 4. So that means the exact opposite of everything less than 4 is 4 and up. So 4, 5, and 6. So now if we have A or B bar, we're going to combine event A and event B bar. So A is 2, 4, 6. So 2, 4, 6. So we have that in common with B bar. But the only thing we're missing now is 5, and we could put that in A or B bar. And so the probability of A or B bar is going to be, we have 4 options here. It'll be 4 out of 6. And that's essentially 2 out of 3. And that is 0.6667. Let me rewrite this. 0.6667. Okay, moving on to K, event and roll a prime number. So out of 1 through 6, we have a couple prime numbers. Remember, or prime number is a number that you get only if it's multiplied by 1 or itself. So in this space, the prime numbers will be 2, 3, and 5. You can Google if you need to. All the prime numbers are available, and see what the prime numbers would be going up to 6. But here we have the prime numbers here. So that means the probability of getting a prime number is just 3 out of 6, which is 1/2, which is 0.5. Okay, last one is roll a 7. Well, here we only go up to 6, so there's no chance of rolling a 7 on the 6-sided die. So that means that the event I is just a blank set. It's empty, there's nothing in here. And so the probability of rolling a 7 means you have a 0 out of 6 chance, which is just 0. Let me just fix this really quick. 0.6667. But okay, so that is this self-check video for section 3.1. Thank you for watching, and I'll see you next time. Thank you. Bye.